Let's take a look at the pretest for 1.1 to 1.4. This video is going to go super fast. I want you to make sure that you know that at any time you can stop it to review any of the stuff that I've done. If you have questions on any of the sections, please feel free to go back to any of the other videos that we've looked at in order to get to this point. Converting radians to degrees. I want to get rid of the radian and turn it into degrees, so I multiply by 180 over pi. The pi's are going to cancel, and I get 180 divided by 2, which is 90. It's going to be 90 degrees. That's something that comes from the unit circle. Pi over 2 is 90 degrees. Okay, that's something that you should already know. 180 over pi again, we're doing the same exact thing. The pi's are going to cancel. This time I have 2 times 180, which is 360 divided by 5. If I take 360 and divide it by 5, I get 72 degrees. Last one. Pi's are going to cancel. 10 goes into 180 18 times, so I can reduce that fraction too. And so ultimately I just have 17 times 18, which is 306 degrees. Convert degrees to radians, so this time I want to get rid of the radians, or the degrees, and so the 180 is going to go on the bottom. And ultimately I'm going to leave this with the pi in there, so I'm going to do the 135 over 180, and I'm going to reduce that to get me 3 pi over 4. Okay, I want to leave that pi in there. I don't want to multiply by 3.14, although I could. I don't want to. So I'm going to do pi over 180, and I do 18 divided by 180, which is actually a pretty nice number because 18 goes into 180 10 times. So I end up with pi over 10. And then the last one, we end up with 165 over 180, 11 twelfths pi. Yep. Number 3. Number 3 has 2 answers to it. Okay, identify 2 coterminal angles, one positive and one negative. So the first one that I'm going to find is I'm going to add, I'm in degrees, so I want to stay in degrees, so I'm going to add 360 degrees to it. So if I take negative 110 and add 360 to it, I'm going to get 250 degrees. Yeah. The second one is going to subtract 360 degrees. I'm just going to go around the circle in the other direction. And here's my first coterminal angle. Here's my second coterminal angle. One's positive, one's negative, so I answered all of the questions. Part B, it says to keep in radians. Well, it doesn't look like it's even in radians, but it doesn't have that degree mark, and so the decimal means that doesn't change the fact that it's in radians. So I want to keep it in radians. Well, in order to find a coterminal angle in radians, we've said, well, you need to add 2 pi. Well, if I add 2 pi to this, and I leave it in 2 pi, then that's really my answer. It's 4.5 plus 2 pi. I can't really do much with that. But if I turn this 2 pi into a decimal, and we do 6.28, and I do 4.5 plus 6.28, I get a 10.78 for a coterminal angle. Either one of those are fine. I'm going to turn it, if I have a decimal, I'm going to turn it into a decimal, and it'll work out just fine either way. So that's my positive one. My negative one is going to be the going around the circle the other way. 4.5 minus 6.28, which gives me negative 1.78 for my negative angle. And those are angles. They're distances around the outside of the circle. Okay, so that's an important thing to keep in mind, that that's what radians actually is representing. Find the arc length. So we had a formula where arc length equals theta times the angle times the radius. Okay, so I've got the radius is 3, essential angle, which is pi over 4. And so my arc length is 3 pi over 4. I don't have to turn it into a decimal if it already has the pi in it, and that's okay. Thing to remember about arc length is that the angle needs to be in radians. So when I look here at this 72 degrees, that 72 degrees is not in radians, it's in degrees. So I need to take that 72 and multiply it by pi over 180. Which gives me 2 pi over 5 when I reduce it. And then I have a radius, but the diameter is given to me. If you think back to geometry, radius is half of the diameter, so the radius is equal to 5. So now I finally can plug it in to my formula because I have all the stuff that I need. I've got a radius and a central angle of 2 pi over 5. Multiply those two things together, and the 5's are actually going to cancel each other, and I get an arc length of 2 pi, or all the way around the circle. The area of a sector, we had the area of a sector formula. It is equal to 1/2 r squared theta. So then we have area equals 1/2. The radius they gave us was 2 squared, and theta is in radians, so we're good on that. So I've got a equals 1/2 times 4 times pi over 2. Half of 4 is 2. 2 times pi over 2 is just equal to pi. So I get an area of 3.14 or pi. In the next one, I've got a radius of 4.3 and the central angle is 198 degrees. Again, 198 degrees is not what I want to leave it as. So I'm going to multiply this by pi over 180. And when I reduce that, I get actually 11 pi over 10. So I have the area again equals 1/2 the radius, which is 4.3 quantity squared times 11 pi over 10. 4.3 squared is going to give me 18.49. And then just going through, half of 18.9, 0.49 is 9.245. If I multiply that times 11 and divide it by 10, I get A is equal to 10.1695 pi. And any version of that, if you were to actually take that and multiply it by 3.14, because you already have a decimal, that's going to give you approximately 31.932, and that would be fine too. You could do that as well. Just to save us some time on this video, I drew in the reference angles, or the actual angle, and then what I'm looking for is the reference angle. So in 125 degrees, here's the angle, and that's the angle that I want. Well, if I look, that's a semicircle, it's 180 degrees, so if I had 180 degrees and I took away this part, which is the angle that we have, so if I did 180 minus 125, that's going to give me the part that's in red, which is the reference angle that I want of 55 degrees. So same thing happens here with 5 pi over 4, except we're in radians. And so the part that, if I look at this, I'm over 180 degrees, and this is the part that I want of this angle. And so if I were able to take this part away, then I'm ultimately looking at what my reference angle is. So if I take 5 pi over 4 and I subtract pi from it, because 180 degrees is pi in radians, then made a common denominator, multiplied both top and bottom by 4. 5 pi minus 4 pi gives me 1 pi over 4. 3.8 is a reference angle, or an angle that looks like this, and so we're kind of in the same situation, except that I'm not going to take away a pi in the pi form. I'm going to take away pi in the decimal form, because I have a decimal, so I'm going to take away 3.14, from that 3.8, which gives me a 0.66 as my reference angle. 332 degrees, my reference angle is this one right here. Well, what I want to take away is I want to look at this whole thing that I just completed a full circle all the way around. But if I take that full circle and I took away all of this part, the angle, so if I took 360 and took away the angle, I'm going to end up with the reference angle here of 28 degrees. Good. On the worksheet that we did, a lot of the angles were in negatives, so going in the negative direction. So you should be prepared to do some of that as well on this sheet. The next one, number 7, I'm looking to go through and determine the 6 trig functions. So the 6 trig functions. Look like that. Given that theta passes through the point 5, 12. So number one thing in trigonometry that you should do is you should draw a picture. Make sure you have a general idea of what this actually looks like. So 5, 12, there's no negatives in there, so I'm over here in quadrant number 1. And I went 5 on the x and 12 on the y. That's this point right here, 5, 12. And so what I ultimately need to do is in order to do the 6 trig functions, I need my other side. And so I'm going to do 5 squared plus 12 squared is equal to c squared. A squared plus b squared equals c squared. So I get 25 plus 144 is c squared. 169 equals c squared. Take the square root of both sides. And I get 13 is equal to c. I get plus and minus when I take that square root. But the minus part doesn't make any sense in terms of what we're looking at here. So this side is 13. So now I can go and create my trig angles. The sine is equal to y over r. And so I've got 12 over 13 is the sine. In terms of what we just talked about with reference angles, here's the reference angle. And so if you are comfortable with SOHCAHTOA, you could also say that sine is opposite over the hypotenuse. Okay, that would be the same thing. Okay, all of these things are really saying the same thing, just looking at it inside the coordinate plane or not. Cosine is then going to be adjacent over hypotenuse, or x over r. Tangent is going to be opposite over adjacent. Cosecant is going to be the reciprocal of sine, so 13 over 12. Secant, reciprocal of cosine, and cotangent, reciprocal of tangent. Okay, so determine the exact 6 trig functions. Given that sine of theta is negative 2 over 3 and cotangent is less than 0. So I've got a sine being opposite over hypotenuse. So I can guarantee that my triangle either looks like this, okay, with a sine, the y value being negative, so it doesn't look like that. So y value being negative is going to look like this. Or it's going to look like this. Okay, it's one of those two. Okay, and both of them have a hypotenuse of 3, and they both have an opposite angle of negative 2, or an opposite side of negative 2. And so in terms of what I'm looking at here, here's my reference angle, or here's my reference angle. One of those two things is true. I just try to draw this a little bit more, so maybe it makes a little bit more sense in the coordinate plane here. It's one of these two triangles, because my y value is going to be a negative 2, and my hypotenuse is going to be a 3. Okay, and so I have one of these two triangles is what I'm looking at. The thing is that I need to decide, is this going to be positive on this side, or is it going to be negative? And that's where the extra piece of information comes from here. The cotangent is going to be negative. So that means that when I take the x over the y value, I'm going to end up with a negative number. So that means that if I had, if it happened to be this triangle, this would be a a negative number. And a negative divided by negative would be positive, so it can't be that triangle. Okay, and so this is all about just deciding what the triangle actually looks like in terms of this this picture. Now, if you don't want to look at the triangle in the picture, then that's fine. You can just draw a random triangle, and you can say, well, this side's -2, and then you can say that this side is 3, and you can find the opposite side by doing -2 squared plus 3 squared is equal to c squared. So this is 4 plus 9 equals c squared. That's not true. So a squared plus b squared, so 4 plus a squared is equal to 9. And then subtract 4. A squared is equal to 5. A is equal to the square root of 5 then when I take the square root of both sides. So I get this side is equal to the square root of 5. If you're doing it in the picture, you still have to do that same thing, and so you have a square root of 5. But it's positive, and I know it's positive because when I do the cotangent, the cotangent of this picture is actually equal to the square root of 5 over -2. And that has to be true. If it doesn't come out to be true, then you're not following what they told us. And so you have to go through and you have to kind of think about this a little bit more than just drawing a triangle and throwing in numbers. Okay, you have to think about where is it on the coordinate grid, or where does the cotangent come out to be negative, and so on. So then I can just keep going through this. So the sine is -2 over 3. And so my cosecant is that flipped over. My cosine is the square root of 5 over 3. My secant is that flipped over, but I have to simplify it, so I end up with the multiplying both top and bottom by the square root of 5. And so I get this. And then tangent is equal to -2 over the square root of 5. Again, simplifying it, -2 square root of 5 over 5. When we look at the solving for missing sides, we're using sine, cosine, and tangent. You are more than welcome to use the other 3 trig functions, but I think we're used to using SOHCAHTOA. Okay. So I end up with tangent of 42, because I have an opposite and an adjacent, equals x over 10. Multiplying both sides by 10, I get x equals 9.004. Rounding to 3 decimal places, just for no random reason. So the part B, I have cosine because I have adjacent and hypotenuse. So cosine of 32 is equal to d over 24. Multiply both sides by 24, and you get 20.353. Part C, I have an opposite and hypotenuse, so I should use sine. Sine of 70 is equal to 15 over r. Multiplying by r on both sides, I'm then dividing by sine of 70, I get that r is equal to 15.963. On number 10, we need to draw a picture. When I draw my picture, it looks something like this. This is a cliff. Yep, so I look at that. I've got an extra 35 feet at the top of the cliff, but ultimately what I'm looking for is this side over here. So I've got an opposite and an adjacent. So I'm going to do tangent of 64 is equal to x over 240. I'm multiplying both sides by 240. Okay, gives me that x is equal to 492. Round your answer to the nearest hundredth of a foot, 0.07 feet. Okay, so that's what x is, but I want the total height of the cliff. The total height of the cliff is that 492.07 plus the extra 35 feet that was on top of what we could see. And when I do that, I get 527.07 feet. Make sure you understand all of these different parts. If you have questions about them, go back and watch the other videos, or make sure you're asking questions in class.